right. Coming up next, I would like to invite Djordje, Senior Staff Data Scientist at Grid Dynamics, who is going to have a presentation entitled Transforming Business Process Automation with Retrieval-Augmented Generation and LLMs. Djordje, the stage is yours.
Thank you. Yeah, hello, everybody. As being said, my name is Djordje Grozdic, and I'm a Senior Staff Data Scientist at Grid Dynamics. I also serve as Senior Specialization Lead for Data Science Expertise in Serbia and Armenia. And before I continue, I would like to give a short introduction about Grid Dynamics, my company. Grid is a leading provider of technology consulting, agile custom software development, and data analytics for Fortune 100 and 1,000 companies undergoing digital transformation. As you can see, we have offices across 18 countries in the world, more than 4,000 developers. In Serbia, we have 3 offices in Belgrade, Niš, and Novi Sad. And speaking of data science expertise, we have more than 120 data scientists and ML engineers, which basically makes us a leader in this area of work in the region. As I mentioned, our clients are big American companies like Apple, Google, eBay, and many others. Okay, so let's go back to today's topic. Today I have a pleasure to talk about Retrieval-Augmented Generation and its application in business process automation, or more specifically, in document processing automation. We live in a world where companies compete and they try to actually automate their business processes as much as possible. And as you know, there are some limitations of traditional document processing approaches, especially if we talk about manual approach. You know, it is slow, it is error-prone, but the biggest pain point here is inability to manage high volume and data complexity. And I believe most of you are familiar with terms like NLP, large language models. You heard about Gen AI, and all these technologies brought some advancements in business process automation to some extent. Large language models obviously brought some advancements in terms of complex and human-like text generation. But still, there are some challenges, especially if we talk about domain-specific tasks. For example, if you're using some large language model, general purpose large language model that is trained on some data set scraped from the internet, so publicly available data, and you try to ask some domain-specific question, probably large language model will not be able to provide you with an answer. Or what is worse, it may provide you with an answer, which is basically a hallucination. And what is hallucination? Hallucination is a plausible sounding answer, but actually a false piece of information. And that's exactly where Retrieval-Augmented Generation steps in. It seamlessly integrates the domain-specific data, and it also reduces the need for continuous model retraining. In case of large language models, you would have to, like when you get new data, to retrain your model, to fine-tune your model, and this is not only time-consuming, it is also pretty expensive. So there are many advantages of RAG. And the first one, as mentioned, is cost effectiveness. Then data security. It also provides greater explainability. It minimizes hallucinations. And I will talk about these things in the following slide. Okay, so for those who are not familiar with the term Retrieval-Augmented Generation, let me try to explain it. We mentioned it in a previous presentation as well. So RAG is a machine learning approach that combines the strengths of information retrieval methods with generative capabilities of large language models. And this is a high-level architecture. It consists of 2 main components, retriever and generator. The job of a retriever is, of course, to take a question or a query right? And to look up into some domain-specific knowledge database and to try to retrieve some relevant documents and answers, right? And then these relevant documents are passed along with a query to a generator. And generator is basically some large language model, and it could be a general purpose large language model. Now, this model, given this query and relevant data, will be able to provide an accurate answer. And that's the whole logic of RAG. Let me tell you something more about RAG in practice. So there are many use cases. For example, in supply chain, RAG could be applied in B2B sales, for example, as part of some automatic form filling app. Then it could be used in supply chain management, in automatic reporting, in automatic validations or compliance checks when you have some document that needs to be validated against some other document that is stored in your knowledge database. Then in retail industry, we can apply it as part of product recommendation system. It could be used in marketing as marketing campaign analysis, also as part of feedback analysis for analysis of customer feedbacks. Then again, as part of a chatbot, like previously mentioned, especially for customer support, it could be really beneficial as part of some product query chatbot. So RAG here will basically allow users to get really precise and accurate answers related to some products of some company or services that some company is providing. Then in finance and insurance, for example, in automation of insurance claims and processing, in portfolio management, in financial reporting, in financial consultation, again, as part of some chatbot, like financial advisory chatbot that will give you some like economics and finance advices. And I don't have time to go too much into detail in each of these use cases, but I will try to do a deep dive into RFP processing with RAG. And what is RFP? RFP stands for Request for Proposal. This is basically a document issued by some company when seeking proposals or bids from some other company that might be some supplier or service provider. And Grid Dynamics is basically a service providing company, which means that we are constantly getting and receiving RFP documents. There are a set of questions, usually in the form of Excel spreadsheet or some Word document, and this is the flow that we manually do. First, we download this document as an attachment from the email, open the document, quickly we run through all these questions, try to understand this document, the main pain points, concerns, and requirements from a customer. And then what we do, we try to answer these questions one by one. Questions usually ask for some advices about how to solve some problem, about previous experiences of our company, about references in some areas, and so on. So in order to precisely answer these questions, we need actually to take a look into documentation of our previous documents of our products and services and so on. So it's a tedious process, and it could be definitely automated. The workflow looks like this. So as I mentioned, we first have a preview of a document, then we have answers generation, then if needed, we can refine these answers, and finally, this document is sent back to a customer. So we built an app for this process, and this is the workflow. We have a user who is able to upload first some documents, this RFP file, for example, and a bunch of other documents. For example, product-related documentation, company-related documentation, whatever. Whatever user thinks should be placed into knowledge database. And of course, we assume that we already have some database, some storage with some documents. Then a user will get a preview of this document. Like I mentioned, the app will automatically detect questions, it will do the parsing, extraction of questions, and it will give a preview of these questions. User will be able to read them, and he will also get a text prompt where he can type a question and ask some things related to this document. For example, give me a summary of this RFP file, or what are the main concerns and requirements and requests from our customer, or something more complex, for example, how to win this opportunity. And large language model in combination with RAG will generate a list of hints that will tell you how to answer all these questions, and it will actually help you to maximize your chances of winning this opportunity and getting a contract signed with your client. And after that, the next step is actually automatic generation of these questions. Again, a user will get a preview of these questions and answers. He'll be able to select any of these answers, and if needed, he can refine these answers manually, or again, using some text prompt. For example, he can say, make a shorter answer, change the style of the answer, or something like that. And finally, when he's satisfied with the quality, he can hit the button and export the final document and send it to a client. And as you can see, the whole process could be fully automated. But still, we left some areas where user can interact with this process flow, where he can see some intermediate results, take some actions if needed. But generally speaking, the process flow could be automated 100%. Now, I have a demo video of this app, but unfortunately it's 10 minutes long, so I will skip it. And anyone who is interested into this topic, please check out our stand in the main hall. We will have this demo video of this app and some other apps that are based on Gen AI. Now, let me jump in into architecture of RAG. This is the main process flow. It consists of several steps. First, as mentioned, we start with documents, so we have some document loading. Then we have document chunking, or splitting documents into smaller pieces. Then vectorization, or turning this text into vector representations, into embeddings, right? And then these vectors are stored into some database called vector store. And we have the similar flow for questions or queries. So when we receive question, which is basically, again, some text, it should be converted to vector space. So we use the same embedder as in the previous step to create a vector, and then this vector is compared with all the vectors from a vector store in order to find the similar ones or the relevant vectors. And that's basically that part of a work that Retriever does. Then, basically using some kind of a similarity measurement technique, we will retrieve only set of relevant documents, actually vectors, and corresponding document chunk IDs. And based on these IDs, we will retrieve document chunks, and then these chunks will be sent to a large language model along with a query, and document chunks are actually context that we are sending to a large language model. And given such prompt, large language model will be able to provide and generate some answer. So this is a simple process flow. It works like that. It's pretty straightforward. If we want to build RAG pipeline, there are some mandatory components, like I mentioned, and I will once again go this time a little bit more into details about each step. So we have a document loading component. Usually we work with unstructured type of data and files. So we have text files, PDFs, Word documents, Excel spreadsheets, JSON, HTML files. We can work with code files. Speaking of structured data, again, we can use a relational database. So basically, the job of a document loader is to load data and do a bunch of different data processing stuff, like text extraction, parsing, cleaning data, formatting, and so on. And I also put here just a bullet point pointing to LangChain, a really useful tool for those who are not familiar with it. Definitely you should check it out. It has great capability to process over 80 different document types. And I believe this number of document types that are supported by LangChain increases in each month. So the next component is document splitting. Okay, so why do we need to actually split documents? First, documents could be really large. And what is more important, you know that large language models have some limitations in terms of the size of the input context, in terms of number of tokens. So that's why we need to split our text into smaller chunks. And there are, of course, different approaches and methods on how to do it. On the right part of the slide, you can see one illustration. Basically, this is just some sentence split into 5 chunks. This is just illustration. Usually, we work with bigger documents and bigger chunk sizes. But here, we can see if we try to read each of these document chunks, we'll figure out that we are losing the context of the sentence. We are losing the semantic meaning and idea of the sentence. So what can we do? There is a simple fix. We can introduce overlapping between these chunks just to keep some context. And yeah, so fixed size chunking with overlapping is something trivial, and it works. But there are also some advanced methods on how to split the documents, the so-called content-aware methods. So we let some algorithm to detect, for example, sentences or some paragraphs or chapters in a document and use them like that. Again, when we talk about size of a chunk, we can measure it in number of characters, in a number of tokens, words, sentences, whatever. And when we talk about sentence splitting, it could be done in many ways, like simple detection of delimiter, full stop, space, or something like that. Sometimes that's enough. Sometimes we need to use some advanced NLP techniques to find the end of a sentence. There are also more advanced approaches like recursive chunking. It starts from the whole big document and then recursively creates smaller chunks, and also it creates a hierarchy, so you can go back and forth from smaller data chunks to bigger ones if needed, and you can pick the optimal size of the chunk. And when it comes to choosing optimal chunk size, this is not an easy task. There is no rule of thumb. Basically, you need to run a series of experiments to understand your data and to pick the optimal chunk size. Next component is text embedding. So conversion of plain text into vector space. Why do we need it? Well, obviously, in vector space, we can easily calculate the similarity between vectors, between text chunks. We can find and measure this semantic relationship, which is pretty important. And again, just for illustration purpose, on this figure here, you can see a couple of vectors for cat, pet, and dog, all animals, all living beings, and they're grouped together. But a vector of some other word, car, in this case, it's an object. It's pretty far away from this group of animals. We do the same for sentences and bigger text chunks. When we talk about models and embedders, again, the same story here. we have different approaches. We have some traditional models like Virtual-Vec or GloVe, but nowadays the standard are transformers. So we use transformers such as BERT, Roberta, Electra-based models, and so on. And speaking of vector store, this is again something that you need in this pipeline, a place where you keep all vectors. I will just name some popular ones like ChromaDB, Elasticsearch, VB8, Pinecone, Milvus, and so on. Again, when you consider choosing one, it always ends up with making balance between precision, speed, and storage efficiency. And now the next component is document retrieval. As mentioned, its job is to retrieve only relevant documents. Here again, different kinds of similarity measurement techniques could be used. We can use something similar like cosine similarity, but there are also some more advanced methods like maximum marginal relevance, then similarity score threshold, where you can set the score of similarity for the returned relevant documents, and this way you can filter out the number of documents that you're interested to work with. And then there are also more advanced approaches, like the so-called large language model aided retrieval. And here we have pre-trained large language model that helps us to actually find the relevant documents. Finally, we have answer generation part. As mentioned, the main point here and the main role plays large language model. But the question is, how should we send relevant documents and context to this large language model? We can do it in numerous ways. The most primitive way is to take all relevant documents as a context and to send it along with a query to large language model. And this works okay for some straightforward questions, but the problem and issue here is, again, content window size. So if we have many relevant documents, you should check out some of the more complex approaches and advanced methods like MapReduce method, refine method, or MapRerank method. And what's the idea here? They all use either iterative approach or parallel approach of sending relevant documents to large language models. In case of MapReduce, we have obvious parallelization. All relevant chunks are sent to a large language model. Then all outputs or answers generated by large language models are grouped together, sent to another large language model, and it will decide which answer is the best, or it will generate a new answer based on these inputs. In case of refine method, we have iterative approach, so we send relevant document chunk one by one to a large language model, and then send it to the next, the generated answer is sent to a next large language model along with the next answer and relevant chunk, and till we get to the final answer. And MapRerank method actually, again, process everything in parallel, but it also produces some metadata or rank score telling you which answer is the most appropriate and accurate, and you will pick the highest score, and that will be your final answer. This is the final slide, the conclusions, and also advantages of RAG over general purpose large language models. As mentioned, data integration is really easy. Basically, all you need to do is to upload your new data to some data storage, for example, to some cloud blob, for example. of course, this data needs to be vectorized, which takes some time, but still this is faster approach than retraining a large language model with a new set of documents and data. And it is not only slow, it's also expensive, so obviously the next advantage is reduced costs. What is really important for RAG is enhanced security, which means that sensitive data remains in the document store and it is not exposed to the model. And also, if needed, we can add some real-time restrictions for some documents. Then something that is really important is greater explainability. This is really important because all responses and answers could be traced back to their sources. So it means that basically the answer is paired with some metadata, which tells you, okay, this answer was generated based on this source document, and it's really important and useful. Then we also have, as mentioned, reduction in hallucination and overcoming context size limitations. And that's all from my side. Thank you for your attention.
Thank you very much, Djordje. Now we have a question over there, please.
Hello, great presentation. I just have a couple of questions. How hard is it to catch hallucination, as you say, in models? Because it's really hard. It's similar to the answers, right?
Yeah, I totally agree with you. Nowadays there are two approaches. First one is to use large language model to detect hallucination of some other large language model, but still we cannot replace human. So we need a human to evaluate and to detect hallucinations. That's the tricky part. The benefit of RAG is actually that this hallucination is minimized. And especially if you pair it up with this metadata, like information about source documents, you can easily check out if this answer is made up or not. And in case of RAG, it's usually not a hallucination.
Okay, thank you. Another question. For the document loader, it uses a lot of files and everything. So do you have a guideline for, does it need to be properly structured or something like that? Or is you can just pull anything and it's
yeah, you can, yeah, definitely it depends on the way how you design your solution and that component of that data loading. You can again orchestrate and group together similar files or files with the same extension and process them in one process, and in parallel process you can process, for example, PowerPoint files or something like that. Again, it depends, of course, on your infrastructure, how powerful is your machine, your cloud instance or something like that. But generally speaking, I think there is no need to create some fancy approach in just selecting different types of documents. Maybe you can even process them one by one in any order.
Yeah, but it would be easier if you for best results, do this, you know.
Yeah.
Okay, thank you.
We have one more question here.
Hi, great presentation. I wonder what model are you using in your application?
What model?
Yeah.
Yeah, so you mean large language model?
Yeah. I mean,
we tried different kinds of models, like some pre-trained models from Hugging Face, but it turns out that actually GPT-4 gives the best results. We also tested Claude, which also provides pretty precise and answers with satisfied quality, but in the end we stayed with OpenAI GPT.
The reason why I ask is because I think in this latest update they have introduced this built-in RAG, right? And
yep,
in Microsoft Copilots you can have the same functionality. Yep. So my question is whether you can now eliminate your custom development, basically just uploading directly?
Honestly, I haven't checked this latest functionalities released by OpenAI. If I'm not mistaken, they released this 2 weeks ago or something like that. Back then, when we were testing this, it was April this year or something like that. But yeah, definitely you're right. This is a good question, and it seems that OpenAI products are becoming more and more powerful, and that it will actually save our development work and development process.
Yeah, and one more comment. I really like this RFP use case, because sometimes we spend a couple of weeks filling it in, and then for nothing, basically, because we end up losing the case.
Yep.
But you said this system can help winning the case. So I was thinking, because in RFP process you can fine-tune it however you want and spend as much time as you want, but at the end, like, price is the deciding factor. So it would be nice to predict some kind of competitor estimate.
You're right, but like, it depends on your company. If your company is competitive in terms of price, then you shouldn't worry about it. And if you have that price in your document storage, then you're fine.
Okay, thank you.
All right, thank you very much, Djordje. And I would like to express my appreciation through this this certificate. Thank you very much. Thank you guys for the questions.
Thank you.
Now